Experiment 1. Basic measurement, length, volume, and density. This experiment has two objectives, which is to determine the volume and density of the ball bearing and to determine the volume and density of glass block. The apparatus that needed for this experiment is vernier caliper, micrometer screw gauge, ball bearing, weighing scale, and glass block. The procedure of this experiment. For the micrometer screw gauge, first, the zero error has been determined. Next, the diameter of the ball bearing has been measured using micrometer screw gauge. The ratchet knob has been turned once a click sound heard. Step 2 has been repeated 3 times at different positions of the ball bearing. After that, all data has been recorded in the table. Next, the actual diameter reading has been calculated taking into consideration the zero error that was obtained earlier. Next, the width of the ball bearing has been measured. And lastly, the density of the ball bearing has been calculated. For the vernier caliper, first, the whole number of small divisions on the fixed part of the caliper that are to the left of the zero mark on the vernier has been counted to give the size of the object to the nearest number of whole millimeters. Next, the first mark on the vernier that line up with one of the marks on the fixed part of the caliper has been found. The value of the mark on the vernier then tells fraction of a millimeter that are needed to complete the estimate of the size of the object. Next, the zero error of the vernier caliper has been determined. After that, the length, width, and thickness of the block has been measured by using the vernier caliper. Step 2 has been repeated 3 times at different positions of the glass block. Next, all data has been recorded in suitable table. After that, the actual measurement has been calculated by taking into consideration the zero error that obtained earlier. After that, the width of the glass block has been determined. Lastly, the density of the glass block has been calculated. These are diagrams of two experiments. These are the results obtained for observed reading. These have zero error with negative 0.05. This is true reading. These are results for observed reading. These have no zero error. These are results for true reading. The analysis of this experiment. Discussion. In this experiment, micrometer screw gauge and vernier caliper have been used to measure the diameter of ball bearing and to measure the length, width, and height of a glass block respectively. Micrometer screw gauge is an apparatus used for measuring accurately the diameter of a thin wire or the thickness of a sheet of metal. The screw has a known pitch, such as 0.5 mm. Pitch of the screw is the distance moved by the spindle per revolution. Hence, in this case, for one revolution of the screw, the spindle moves forward or backward 0.5 mm. This movement of the spindle is shown on a engraved linear millimeter scale on the sleeve. On the thimble, there is a circular scale which is divided into 50 or 100 equal parts. Therefore, the micrometer screw gauge has a sensitivity of 0.01 mm. The conclusion. In the end of this experiment, it is found that Micrometer screw gauge and vernier caliper can be used to measure accurate measurement for diameter by using micrometer screw gauge and length, width and height of object by using vernier caliper with respect. There are no zero error. Zero error has been deducted. In conclusion, performance measurement plays an essential role in creating public value through effective strategic management. The work of developing and improving performance measurement system involve philosophical and normative as well as scientific and cognitive issues.
Assalamualaikum, my name is Nur Izzatul Fakihah binti Zamaluddin and my partner is Nur Syafiah Humaira binti Luqman. We are from RAS 101D and our lecturer's name is Puan Zalina binti Zainal Abidin. So we are going to present experiment 5, which is Hooke's law. The objective for this experiment is to verify the accuracy of Hooke's law using spring. Apparatus for this experiment is helical steel spring, supporting stand, scale, set of slotted waist, hanger and waist balance. Moving to the procedure, first, mass of hanger was measured and recorded. Second, width of the hanger was calculated and recorded as W in the table. Third, the scale was adjusted so the pointer on hanger was near the upper end of the scale when the hanger has been unloaded. Its position was recorded as X note. Fourth, the hanger was loaded by 10 gram mass and the scale reading X1 was recorded. The load was kept increasing with suitable increment to obtain 8 data points before the lower end of the scale was reached. The fifth procedure is the process was reversed by unloading the same load as in procedure number 3. New scale reading X1 was recorded again for each loop. Next, the extension of the spring has been calculated and last, the extension force acted on the spring was determined for each total load. Here is the result for the experiment 5. This is the graph force causing the extension F against the extension which is F. So next, we can find the gradient of the graph. The formula for the gradient of the graph is distance of y over distance of x. So we can get the gradient of the graph is 0.0339 and the gradient of the graph represents the speed of an object. Next, to find the work done in stretching the spring through 0.20 m from the graph, we can use the formula work equals to area under the graph. So 1 over 2 times by 0.59 and times by 0.20. So we can get the work done in stretching the spring through 0.20 meter is 0.059 Newton. For energy stored in the spring when it's extended to 0.20 meter, we can use F equal to Kx. Then we want to find the K and the formula is K equals to F over X. So 0.59 over 0.20. So we can get the K is 2.59. So we can find the energy using 1 over 2 Kx square and 1 over 2 times by 2.95 and times by 0.21 square. So we can get the energy stored is 0.059 joule. Parallax error may be occur when measuring the stretch length of the spring because I may be positioned at angle to the measurement marking. Hooke's law describes the relationship between the extension of the spring and the force causing the extension. According to Hooke's law, the force exerted by a spring is directly proportional to the displacement or extension of the spring from its equilibrium or rest. Mathematically, it can be expressed as F equal to Kx, where F is the force exerted by the spring K is the spring constant, a measure of the stiffness of the spring, and X is the displacement or extension of the spring from its equilibrium position. We can conclude that Hooke's law is one of the fundamental principles in physics that defines the relationship between mass exerted and the extension of an elastic material. Mass is the quantity of matter in an object given in kg, and every free object is acted on by the gravitational force of acceleration, giving its weight. According to Hooke's law, whenever weight is exerted on a vertically hanging spring, it extends. The extension is directly proportional to the force causing the extension. The Hooke's law states that the stretch of spring is directly proportional to the force that applied. Therefore, the experiment shows that the Hooke's law is proved when we doing the experiment and edit the loaded mass. Second, repeat the experiment twice and get an average to get a correct reading. Third, put the loaded mass carefully to avoid spring stretch and to avoid spring achieve the limit. And lastly, the eyes also must be perpendicular to the reading scale of the meter ruler. That's all from us. Thank you.